Himeji Castle holds a special place in Japan's history. Built in the Middle Ages, it has survived civil wars and world wars. Not bad for a wooden structure. But it is the timeless geometry of this castle that makes it most impressive. It is a case study in the creative use of angles. Himeji Castle served as a fortress where samurai armies could defend themselves from an attacking army. So Himeji Castle was built to make it difficult for an army to invade and easier for those inside the castle to defend themselves. Let's look at how angles play a key role in Himeji Castle's defenses. Let's first start with its altitude. Like many castles and fortresses, Himeji is a tall structure, and made all the more taller because it is situated on a hill. The total height of Himeji Castle is 92 meters, or about the length of a football field. The advantage of a tall structure is that it increases the line of sight to the horizon. This makes it much easier to see an invading army from farther away, allowing those in the castle to prepare defenses. This is how line of sight works. Imagine a structure sitting on the Earth's surface, which is drawn as a circle. Draw a line from the top of the structure to a point on the circle. A line that intersects a circle at one point is tangent to the circle. Now imagine a taller structure. We draw another line from the top of this structure to a point tangent to the circle. Comparing the first line of sight diagram to the second, you'll see that as the structure's height increases, the more of the Earth's surface it can see. The line of sight improves for taller buildings. Let's explore the angles generated from line of sight on the TI-Nspire. Turn on the TI-Nspire. Create a new document. You may need to save a previous document. Create a Graphs and Geometry window. Create a circle. Press Menu, and under Shape, select Circle. Move the pointer to the middle of the screen and press Enter to define the center of the circle. Next, move the pointer away from the center to define the size of the radius. Press Enter again. Construct the tangent to the circle. Press Menu, and under Points and Lines, select Tangent. Move the pointer to the circle near the point that would correspond to 1 o'clock if the circle were a clock face. Press Enter. Try to get your screen to look like this. If you need to move the point, simply highlight it and use the nav pad to move the point along the circle. You now have a line tangent to the circle. You'll now construct a line segment from the center of the circle to a point on the tangent line. Press Menu, and under Points and Lines, select Segment. Move the pointer to the center of the circle. The pointer should change to a hand. Press Enter. Move the pointer straight up until it intersects the tangent line. You should see a text message next to the pointer saying Point On. Press Enter. Repeat this to create a segment from the center of the circle to the point where the tangent line intersects the circle. You should now have a triangle with vertices at the center of the circle, on the circle itself, and on the tangent line. This is a model of the line of sight. The portion of the segment above the circle represents Himeji Castle. The line of sight is one of the sides of the triangle. Let's now explore the angle measures involved. Use the Angle Measure tool. Press Menu, and under Measurement, select Angle. With the Angle Measure tool, you need to define the 3 points that make up the triangle. You will be using the vertices of the triangle. Take turns marking the 3 points that make up each of the angles of the triangle you have constructed. Press Enter each time you have highlighted one of the points. try to get your screen to look like this. When you are done, press the Escape key. First, notice that the angle formed by the tangent and the radius is 90 degrees. Even if you manipulate the vertex, the angle remains 90 degrees. And in fact, this is a property of all tangents to circles. They are perpendicular to the radius at the point of intersection. This means that the line of sight angle is an acute angle, or an angle less than 90 degrees. Let's change the height of the tower to see how the line of sight changes. Move the pointer to the point on the tangent line. Select the point by pressing and holding the click key. Move the point upward. Notice how the height increases. Because the point is on the tangent line, the point will move up and to the left. Go to the point on the circle and move it clockwise until the line representing Himeji Castle is vertical. This movement of the point of the circle represents the increase in the line of sight. Notice also that as the height of the structure increases, the acute angle decreases in size. Himeji Castle rises high in the air so that it has a long line of sight to the horizon so that it can identify attackers from a long distance. The line of sight forms a line tangent to the arc of the Earth's circular shape. What is the length of this line of sight and how can we use it? Because the tangent and the radius form a right angle, the triangle that you created earlier is a right triangle. So the line of sight distance is one of the legs of the right triangle. Also, the radius of the circle is actually the radius of the Earth. We can create an equation to solve. Let's use variable h for the height of the castle, r for the radius of the Earth, and L as the line of sight distance. Using the Pythagorean theorem, we get the equation L squared plus R squared equals the quantity h plus R squared. Solving for L, we get the expression the square root of the quantity h squared plus 2hr. We know that h, the height of the Himeji Castle, is 92 meters. The radius of the Earth is roughly 6.4 times 10 to the 6 meters. Plugging these values into the formula for finding L, we get that the line of sight distance is about 34,316 meters, or about 21 miles. Given that an invading army travels at a fairly slow speed, the lookouts on Himeji Castle, with their commanding view of the countryside, could prepare for imminent invasion with hours to spare. And what would be in store for the invaders would be more hostile geometry. The grounds surrounding the castle are vast, and there are plenty of obstacles on the way to the main tower. First, like many castles, Himeji has a moat surrounding the castle grounds. Second, there is a high wall behind the moat enclosing the castle grounds. There is a bridge near the main entrance, and an invading force would move in this direction. But once inside and past the main gate, the grounds become a huge maze, with various pathways leading to dead ends. The long winding path through this maze is actually a spiral path to the main tower. Moving along a spiral path means that you turn 360 degrees, or one full circuit from your initial position. You can see this on the Nspire. Activate the segment tool. Construct an angle. First, create one side of the angle, pressing Enter for each endpoint. Then, press Enter once again over one of the endpoints. Create a second segment, in the process creating the angle. Now, measure the angle. Press Menu and under Measurements select Angle. After you have measured the angle, press Escape and move the pointer to one of the endpoints as shown. Hold the click key until you select the point. move the point so that the angle measure is 0 degrees. Next, move the point until the measure is 180 degrees. What do you notice? It's a straight line. So if you were to continue rotating the point so that it is back to where you started, this would result in another 180 degrees, for a total of 360 degrees. An invading army would not realize that it is going in circles, since the spiral path is gradually circular. In addition, on its way through the maze, the path gradually becomes steeper. That path has a slope of about 2 degrees. This is an acute angle since it is less than 90 degrees. Try to model a 2-degree angle on the Nspire. As you can see, such a slope is gradual enough that an army would need to travel farther and exert itself more to reach the base of the tower. Finally, upon reaching the base of the tower, the army would be staring at this imposing structure. Seen from the side, the main tower makes an obtuse angle with the ground, or an angle greater than 90 degrees. Also, notice that the line of sight from ground level prevents an attacker from getting a view of the top of the tower, giving the castle's defenders still one more element of surprise in attacking the army at the base of the tower. Himeji Castle's defenses owe a great deal to the way in which angles are used, from the sloping paths where invaders are slowed down, to the blind corners of its Byzantine maze, where defenders could ambush the invaders, to the insurmountable walls of the main tower. The properties of angles are used for defensive purposes. And yet, Himeji remains an elegant piece of architecture that adds majesty and serenity to its surroundings.